The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Alrighty, so are there any questions from yesterday that you'd like to look at before we go on to section 7.5? Anything? Anybody? All right, then we'll go on to section 7.5, which is simplifying complex fractions. So first of all, let's look at what is a simple fraction and what is a complex fraction. Here are some examples of simple fractions. So simple fractions: 1/3, 2/17, x plus 7 over y minus 2. Okay, a simple fraction has a numerator and a denominator. Okay, let's take a look at complex fractions. Complex fractions. An example: 2/3 divided by 7/8. X over y plus 7 over 3 over x divided by 2. So a complex fraction has more than just the big fraction. There might be a fraction within the numerator of the bigger fraction, or the denominator of the bigger fraction, or both perhaps. Okay. The goal is to take a complex fraction and convert it into a simple fraction, and then go from there if we could do anything else with it. But the main thing we're going to focus on is taking complex fractions, converting them into simple fractions. All right. There are two different methods that we can look at. The first method is if we have a complex fraction that just has a fraction within the numerator and a fraction within the denominator. So let's say we've got 3/5 divided by 2/7. Okay, so there's a single fraction up top, a single fraction on the bottom. This is equivalent to 3/5 divided by 2/7, right? Okay, but dividing by a fraction is like multiplying by its reciprocal. So we get to this point, but now multiplying two fractions together, we just multiply straight across unless there's any pre-reducing we can do. In this case, there isn't any, so 21 over 10 would be the final answer. Okay, let's take a look at another example of that kind of problem. Let's say we've got 9/4 over 7 over x. That's equal to 9/4 divided by 7 over x, which is equal to 9/4 times x over 7. Now we multiply straight across. We can't do any pre-reducing, so we would get 9x over 28. Any questions about that problem? Okay, let's take a look at some slightly more complicated but same idea kind of problems. Let's say we've got 14 over 15m, all divided by 21 over 25m to the 6th power. So that would be equivalent to 14 over 15m divided by 21 over 25m to the 6th power. But that's equal to 14 over 15m times the reciprocal, which would be 25m to the 6th over 21. Once again, at this point, we would multiply straight across, but finally, we can actually do some pre-reducing here. 25 over 15 reduces down to 5 over 3. 14 over 21 reduces down to 2 over 3. M to the 6th over m reduces down to m to the 5th. and we've got 10 m to the fifth over 9, or I'll write that over here, 10 m to the fifth over 9. Okay, let's see here. Any questions about that? All right, now let's look at some more complicated complex fraction. Or would that be more complex fractions? Let's say we've got something like this. 1/2 plus 3/4 over 3/2 plus 1/4. Excuse me. Now, one of the ways we could go about doing this is to take the two fractions in the numerator and get a common denominator and build them up and then combine them into a single fraction and do the same thing with the denominator. And then we'd have a fraction like the previous ones we looked at and deal with it that way. Excuse me, nose is running today. But there's another way we can do it that's quicker. Take a look at all of the little denominators, okay? What is the LCD of 2, 4, 2, and 4? It is 4. What we're going to do now, we're going to multiply the numerator and the denominator of the complex fraction by the LCD, which is 4. Now, the way I'm going to write it out, though, is like this. That's the same thing as 4 over 4, but I want to emphasize that this 4 is in the numerator of the numerator, and this 4 is on top in terms of the denominator, okay? Now, we're going to distribute the 4 here, here, the 4 here, and the 4 there. All right? I'm going to erase that because I want to have some room to write here. So 1/2 times 4 over 1 would be what? That would be 2. Okay? Plus 3/4 times 4 over 1 would be 3. Down here, 3/2 times 4 would be 12 over 2, or 6. And 1/4 times 4 would be 1. So I end up with 5 over 7. And there is your simple fraction. Any questions about that? All right. Let's take a look at another example. 2 over x minus 1/3 all over 2/3 plus x over 5. Excuse me. Okay, I'm going to write this down here. What's the LCD of x, 3, 3, and 5? Anybody? Well, it's going to be 15x. So I'm going to multiply the numerator by 15x and the denominator by 15x. Okay. Let's take this first product. 2 over x times 15x over 1. So that's this times that. The x's would reduce out and we'd have 30. Okay, now let's take this one. Minus 1/3 times 15x over 1. 15 over 3 is 5, so we get minus 5x. Down on the bottom, 2/3 times 15x over 1. 15 over 3 is 5 over 1, so we get 10x. And then plus x over 5 times 15x over 1. The 15 and the 5 become 3 over 1, and we get plus 3x squared. I'll be right back. I'm going to blow my nose. I don't know why. It's just running like crazy today. Sorry about that. All right. Any questions so far on this problem? So now let's see if I can do anything with it. Well, in the numerator, I could factor out a 5. In the denominator, I could factor out an x. But that gets me nowhere. So there's my final answer. Okay. Any questions there? Okay. Let's take a look at this problem. 10 over n minus n over 4, the whole thing over 8 divided by n. So what's the LCD of n, 4, and n? It would just be 4n. So I'm going to multiply by 4n over 1 over 4n over 1. Okay. I'm going to distribute 10 over n times 4n over 1. The n's would reduce out, and I've got 40. Then minus n over 4 times 4n over 1. The 4's reduce out, minus n squared. And finally, 8 over n times 4n over 1. The n's reduce out, and we get 32. Well, I can't do anything to reduce that. So, final answer there. Are you folks following this? Nobody's saying anything, which isn't unusual, but Jordan,
Yeah.
You doing okay? All right. All right. Just making sure. 3/5 minus 2 over 2/5 minus 2. Now, there's an implied denominator of a 1 there and there. So the LCD of 5, 1, 5, and 1 is just 5, right? So I'm going to multiply both sides by 5 over 1. Let's see. 3/5 times 5 over 1 would be 3. Minus 2 times 5 over 1 would be minus 10. In the denominator, 2/5 times 5 over 1 would be 2. Minus 2 over 1 times 5 over 1 would be minus 10. Well, 3 minus 10 is negative 7. 2 minus 10 is negative 8. So we'd end up with 7/8 as our final answer. Okay. Let's see here. Let's take a look at this one. 3/4 plus 1 over y divided by 5/6 minus 1 over y. So our denominators are 4, y, 6, and y. So the LCD would be 12y. Is everybody okay with where I got 12y? If you're not, speak now and I'll go through it. All right. So we're going to multiply by 12y over 1, 12y over 1. Distribute, 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 distribute. So let's see, up here I've got 3/4 times 12y over 1. The 12 over 4 is 3, so I get 9y plus 1 over y times 12y over 1. The y is reduced to 1. Okay. Which is what? 10.
Mr. Mail, we can't see your screen.
Oh, huh. Now something happened there. Let's see here.
You cut out for a little bit.
Okay. Can you see it now?
Yes.
Okay. Yeah. Thank you. I wondered because I saw something happen, but I didn't know what it was. Okay. So we were right here getting 10y. Are we okay there? I guess. And then minus 1 over y times 12y over 1. the y's go and we get minus 12. So we've got 9y plus 12 over 10y minus 12. Okay. Now, in the numerator, I could factor out a 3 and get y plus 4. In the denominator, I could factor out a 2 and get 5y minus 6, but that doesn't really do anything for me, but I had to at least see if there was a common factor I could reduce out. So there's the final answer there, okay? Let's see here. Okay, how about this? 1 over x minus 1, all divided by 1 minus 1 over x minus 1. They just keep making things harder and harder, don't they? So the LCD would be what?
Wouldn't it just be 1?
No, it would be x minus 1. You see that?
Yeah.
Okay. So we're going to distribute. On top, I've got 1 over x minus 1 times x minus 1 over 1. The x minus 1 is reduced down, and that whole thing just becomes 1. In fact, that's the whole numerator, is just 1. Then in the denominator, I've got this, which is 1 times x minus 1 over 1, which is just x minus 1. And then minus 1 over x minus 1 times x minus 1 over 1, which is just 1. So I end up with 1 over x minus 2. I went kind of quickly there. If I lost you, please let me know. I'll go back through it slower. All right. How about this one? 8x minus 64 over y divided by x squared minus 64 over y squared. Now, this is a single fraction divided by a single fraction. So if I wanted to, I could rewrite this as 8x minus 64 over y divided by x squared minus 64 all over y squared, which is 8x minus 64 over y times y squared over x squared minus 64. Okay, do you see that? That's like this very first problems I did. Even though it looks more complicated, it's still a single fraction divided by a single fraction. So I could use this method if I wanted to. Well, let's see. I could factor that into 8 times x minus 8 over y times y squared over x plus 8 times x minus 8. Y squared over y is y. The x minus 8's reduce out, and I'm left with 8 over x plus 8. Okay. I'm going to go back and do this same problem, this latest method that I've been doing, to show you that that works. It's just a matter of which way you want to go. But this method I just use only works when you have a single fraction over a single fraction. The other method where you multiply by the LCD over the LCD, that works on all of them, even those easier ones at the beginning. But let's go back and do this one the other way. So 8x minus 64 over y, x squared minus 64 over y squared. So now the LCD would be y squared. And if we take 8x minus 64 over y times y squared, we get y times 8x minus 64. In the denominator, the y squares reduce out and we get x squared minus 64. Okay. Now, I could factor the numerator and factor out an 8 and have x minus 8. Factor the denominator, x plus 8, x minus 8. reduce those out, and I get 8y over x plus 8. Oh, you know what? I messed up the first way because there was a y right there that I forgot. Shame on me. I thought, well, those aren't the same answer, but they should have been. But yeah, when I reduced that down, I left a y, but I didn't pick it up. So this method, 8y over x plus 8, or this method, 8y over x plus 8. Okay, how about this one? 2a over b minus b over a, the whole thing, 2a over b plus b over a. What's the LCD of b, a, b, and a? It's ab. So 2a over b times ab over 1. The a, let's see, the b's reduce out, and I've got 2a squared minus b over a times ab over 1. The a's reduce out, I've got minus b squared. In the denominator, 2a over b times ab over 1. The b squareds reduce out, I've got 2a squared plus b over a times ab over 1 becomes plus b squared. Looks interesting, but we can't do anything to the numerator or the denominator to make it, you know, factor or whatever. So there's our final answer. Okay. How about this one? 1 minus p plus 2 over p all over 6 over p squared plus 1 over p minus 1. Keep in mind, again, there's all these implied denominators there. Okay. So on top, we've got denominators of 1, 1, and p. On the bottom, we've got p squared, p, and 1. So what's the LCD? P squared. Good. So 1 times p squared is going to be p squared minus p over 1 times p squared over 1 is going to be what? Minus p cubed. And then plus 2 over p times p squared, which would be plus 2p. In the denominator, 6 over p squared times p squared over 1 is 6 plus 1 over p times p squared over 1, which is plus p, minus 1 times p squared, which is minus p squared. Well, let's see. I'm going to rewrite the top and the bottom both in descending power. So on top, I've got negative p cubed plus p squared plus 2p. And the bottom, negative p squared plus p plus 6. Okay. On top, I'm going to factor out a negative p, and I'll have p squared minus p minus 2. And on the bottom, I'm going to factor out a negative, so I'll have p squared minus p minus 6. Let's take a look at that. I'm not done yet, but let's make sure I didn't make any mistakes there. Let's see, factoring out a negative p on top. That looks good. A p on the bottom. Okay, so this is not the final answer yet. Okay. Any questions before I go on? I'm going to recopy that on the next page. So we've got negative p times p squared minus p minus 2 all over negative times p squared minus p and then minus 6. Okay, now I believe I can factor that into p minus 2, p plus 1. And the bottom I can factor into p minus 3, p plus 2. However, having done all of that, all I can get rid of is the negative divided by the negative. Same thing over here. Okay, but I had to investigate just to see. So final answer would be this or that, or even p cubed minus p squared minus 2p over p squared minus p minus 6 without factoring out the p. But you'd still want to factor completely to make sure, because sometimes you miss some common factors if you don't factor it out completely. Any questions there? All right, let's take a look at one more. 3 over ab squared plus 6 over a squared b, all over 6 divided by a minus 9 divided by b squared. The LCD of ab squared, a squared b, a and b squared is a squared b squared. All righty. So 3 over ab squared times a squared b squared over 1. A squared over a is a, and b squared over b squared reduces out, so we've got 3a plus 6 over a squared b times a squared b squared over 1. The a squareds reduce out, a squared over b is b, and we get plus 6b. In the denominator, 6 over a times a squared b squared over 1. A squared over a is a, and we get 6ab squared minus 9 over b squared times a squared b squared over 1. The b squareds go and get minus 9a squared. Wow. Let's see here. I could factor 3 out of the top and get a plus 2b. I could factor a 3a out of the bottom and get 2b squared minus 3a. But all that allows me to do, let's see here, is to get rid of a 3. So I've got a plus 2b over a times 2b squared minus 3a, or you could distribute that a in the bottom and have a plus 2b over 2a squared b minus 3a squared. Oh, and I just remembered people told me that they can't see what's written over here, so let me write that on the next page. A plus 2b over a times 2b squared minus 3a. And there you have it. So solving complex fractions, or I should say simplifying. We're not solving them because it's not an equation. Any questions?
No.
All righty. Well, I will be back this afternoon at 1:15 for an office hour.